I cut the video off a little short on the last one. I forgot to do this last example. So I'm going to add this last example in here. This goes with 3.2b complex numbers. So I want to write it in standard form, so I want to write it as a plus bi, which means that I need to get rid of this denominator. And to do that, I'm going to multiply it by the conjugate. I'm going to multiply it by, instead of 2 minus I square roots of 5, I'm going to multiply it by 2 plus I square roots of 5. I'm going to multiply that on the top as well to keep it equal, equivalent fraction. So on the top, I'm going to, I might do these ones with a box just because it includes some square roots and it gets a little complicated. So we get 3I square roots of 5 and 2I square roots of 5. So 2 times 3 is 6. 2 times I square roots of 5 is going to be 2I square roots of 5. 3 times I square roots of 5 is going to be 3I square roots of 5. And then you're going to have I times I will be I squared. And the square root of 5 times the square root of 5, since both those 5s are on the inside, you multiply that, that's going to give you the square root of 25. Now this last box, I squared really equals -1, and the square root of 25 really equals 5. So -1 times 5, that last box really just equals -5 there. All right, on the other side, or on the bottom here, we have 2 minus I square roots of 5 and 2 plus I square roots of 5. So 2 times 2 is 4. 2 times -I is going to be -2I square roots of 5. 2 times +I square roots of 5 is 2I square roots of 5. Then I times -I is -I squared. Square root of 5 times square root of 5 again will be square root of 25. Since they're both on the inside of the square root, you multiply them together on the inside. Then this is -1, if I substitute -1 in for I squared, so really that's +1. And the square root of 25 is 5, and 1 times 5 is just 5. So that last box on the bottom is 5. So on the top here I'm left with 6 minus 5 is 1. Then combine like terms here. I have 2 of these and 3 of these, so simply I have 5 of them. So I have 2I square roots of 5 and 3I square roots of 5, so I have 5I square roots of 5, combining like terms. Over here, these two equal 0, and that's what I wanted. I wanted to get rid of that imaginary part. And then I have 4 and a +5, so over 9. And then I can rewrite that as 1/9 plus 5I square roots of 5 over 9. So I have A plus BI. So just remember, we want standard form to look like this. Remember to add or subtract like terms. We write the quotient of two complex numbers in standard form by using the complex conjugate. That's if it's A plus BI, the conjugate is A minus BI. All right, thanks for watching.